Hi everyone. Today we are going to talk about abstraction. So the another principle of object-oriented programming is abstraction. So what is abstraction? Abstraction is nothing but you're going to hide the implementation details from the user, right? So whoever is using your classes, you do not want to actually give the user away. You don't want to give your user away the details of how you have implemented the functionality behind it. You want to abstract it. This does two simple things. One is it's actually leads to privacy, and second thing is you are now making the user experience a bit better, right? So as a user, the user did not know how you have implemented things behind the scenes. All the user needs to know is this is the function, and if he calls the function, his job is getting done. So that is what abstraction is about, hiding the implementation details. It actually happens at design time. Design time meaning when you are actually, designing your software, yet you're going to sit together with a bunch of developers and you're going to come up with the design, like how your classes should be designed, which class should be an abstract class. So at that time, you're going to have this abstraction done. Abstraction in Java can be done in two ways. One is through interfaces, and the other one is using abstract classes. Out of this two, actually interface is the best method and it's very, very powerful. So let's talk about both of them. Now, interfaces, right? Now, some of you might wonder that we already have inheritance in place, right? Which we have seen where you can inherit all the properties of your parent class, right? And you can have the only restriction there is that you can only inherit from one parent at a time. Now, there can be a possibility or even a real use case where you want to have, want to inherit from more than one classes. In that case, what you can do is you can, inherit your properties and methods from one class, and then you can implement the interface. By doing so, now you can actually, achieve inheriting properties from more than one classes. Okay. Now, interface is basically it's going to provide provide the user with a blueprint. Okay, blueprint of the methods which needs to be implemented, but here we do not actually tell the user that how it needs to be implemented. So what do I mean by that is, let's take an example. Suppose we know, everybody I hope knows the concept of data structures, right? In data structures, we have two data structures called as stacks and queues. Now, let's say as a user, I want to use a data structure, okay? But now the implementation, so when you say a data structure, there are certain things which come to mind. What is it? You're going to add the data, right, to the data structure, and you're going to delete some data, right? And obviously you're going to traverse the data and so on. But addition and deletion of data are two important things which we'll do for every data structure. Now, but the way you're going to add and the way the data gets deleted from the data structure depends upon the type of data structure. So let's assume we have two data structures here, stacks and queues, right? Stacks is basically your last in first out policy, and this is first in first out policy. So let's say that we have a data structure, stacks and queues are data structure. The addition logic for addition to a data structure, which is a stack, will be different from the logic, the way you would add the data to a queue. Similarly, the way you would delete from a stack would be different from the way you would delete from a queue, correct? So what is here common is we know that both of them are data structures. That means we know that both of these classes or both of these concepts are going to have what? These properties, correct? You could actually perform this by using inheritance, right? What you could do is create a class data structure, and then you could have stacks and queues, you can make them as the children of this data structure class, and you can have the implementation. But there is one slight problem, right? Because you are going to have addition and deletion, these two methods will have their specific implementation. There'll be different implementation for stack class and a different implementation for a queue class, correct? Now, what could be the solution for this? The solution would be that you can say that add class, you can override the add class in the stack class, right? You can also override the add method in your queue class. That means you are basically going to have polymorphism, right? But now think about this. What should be the implementation of this addition function in my data structure class? Is there any implementation I need in the data structure class? No, you actually do not need. But then because you are doing inheritance, what is going to happen? It's compulsion that you have to mention some body for this addition method, right? Similarly, some body for deletion method. That means even it is not required, we are kind of forced to give some implementation, provide some default implementation we need to do, right? Because finally we are going to create or use the implementation which is present in the child classes. When you have scenarios like this, what is better is to use something called as interfaces. Interface is nothing but like a blueprint. In this, you're going to mention that this is a class, and when you say this is a class, when you say this is an interface, okay, you're going to create an interface and say data structure is an interface. Here you're going to just list down the properties which this interface needs to have. Like you're going to say if data structure is an interface, I would need to have addition as one of the method, deletion as one of the method. But the only thing is these two methods are basically abstract methods. What do I mean by abstract method? Means you're simply going to provide the signature of the method without providing any kind of implementation. It's simply stating that data structure is an interface which is going to have two methods here, addition and deletion. There is no implementation to it. So such methods which do not have any implementation but only the signature is present, those are called as abstract methods. So interface is always going to have what? Abstract methods. Okay. Now, when you have these abstract methods, now what about these classes, stacks and queue? Stacks and queue are going to implement the interface, data structure. Similarly, queue is going to implement the interface data structure. Why? When we say implement, this means that now the stack class, okay, this class is going to provide implementation for all the abstract methods which are present in the interface data structure. Okay. Similarly, when you say queue is a class which is implementing the interface data structure, what it means is now queue class is going to provide its custom implementation for the two abstract methods, addition and deletion. Now, it is compulsory for the class which is implementing the interface to provide implementation to all of its abstract methods. Meaning, stack class cannot choose to just provide implementation for addition and neglect delete. That is not allowed. If you are going to implement an interface, you are supposed to provide implementation for all the abstract classes which are present in your interface. Correct? So I hope this is clear, right? If I had to use inheritance, it would have been a compulsion for me to make this particular provide some default implementation for these two classes, which I do not want, right? My use case here is I just want to say that if you want to call yourself in data structure, like suppose if you want to use data structure or you want to model data structure entity, right? You think about that a data structure can do addition, deletion, traversals of data, right? So you're basically saying that these are the list of properties which you would like to have in a concept called as data structure. So such things you can make it as interface. It's simply like a blueprint. Now, whichever class that if you look at this stack, right, this is a class which is implementing interface, means it is going to provide its custom logic for addition, its custom logic for deletion, which is going to differ from queue. So what this interface actually allows us to do is you are actually abstracting away the implementation details of the methods. Right? Because now whenever somebody is going to create an object of the stack class, right? To create an object of the stack class, I can do something like this, new stack, right? Now, because this is implementing the interface data structure, I can assign this to the memory reference of data structure. So I can say data structure stack equal to new stack. Now, what this is going to do is, now this stack is basically an interface, right? Now I can simply call what, because whoever knows this particular interface, this interface will be what, exposed to the user, right? So user just now has to simply say stack dot add. He is not worried about, let's say this is an integer here. He is not worried about how the implementation of this addition method for this particular, in the class stack is done. That is actually hidden from him. He's only worried. He just knows that if a particular class is implemented, the interface data structure, he can be sure that that class is going to have both addition and deletion. So you can be now sure that if stack is implementing data structure, means that stack is actually has, I can perform addition and deletion. Similarly, you can say for queue, now queue, because it is implementing the interface data structure, it actually has, you know, these two methods, additions and deletions. Okay, hope this is clear. Now let's go to IntelliJ and look at this, how the syntax and everything would be. So I have your public interface. The name of my interface is data structures, correct? Now, is there any, what to say, you know, a rule at I can only, you know, have two classes which are implementing interface? No, absolutely not. You can have any, this is just like a blueprint, right? You can have any number of, you know, interfaces, any number of classes which are going to implement the interface, right? That is one thing. Second thing is, might be suppose if I have one more interface, correct? Like for example, this is data structures, might be you have one more interface, let's say algorithms. Okay, now might be it is possible that stack class can implement more than one interface. It is absolutely possible. I can just say here algorithm and it will, you know, it will be okay. And because it's not defined, it's giving me an error, but it should be absolutely fine. So what do we learn from this is, multiple inheritance is not allowed, okay, but multiple, you know, you can implement more than one interfaces in Java. Okay, so that is something to remember. So now I have public interface data structures, right? I have these two methods here. So these are basically abstract methods, right? So there is an addition and there is a deletion. As you can see, this is just the signature and then there is a semicolon. That means it says that I have, this is just the signature. Okay, now you would, some of you who know about abstract, the keyword, you would say that I should add here abstract. Now, as you see, if I added abstract, it kind of changed, you know, it said that modifier abstract is redundant for interface methods. Remove abstract modifier. The reason is, by default, all the methods which are present inside an interface are abstract, because that is the definition of interfaces. You are not supposed to provide any implementation. Okay, so there is no need for you to explicitly go and use the keyword abstract. Okay, that is one thing. Second thing, you can have some data properties, that is nothing but you know, data members or variables inside your interface, but all those variables are of type final, meaning it is by default final. So if I say, I just suppose say int max size, this is going to give me an error. The reason being, it's going to say that you have to initialize the variable maximum size, because this by default, all the properties which you define inside an interface are what? Final properties, right? That means when you create an interface, if you want to define some property, I'm going to say, you know, that whatever property you create, you have to give a value to it, and that value cannot change, right? And this value maximum size can be actually accessed by all the classes which are going to implement the interface. That means which method, which properties should you know, write in the interface? Such properties which are common or which are going to be used by all the classes which are going to implement the interface, those properties you can mention here. Like for example, here I have data structure as my interface, and there are two classes, right? Stacks and queues, which are going to implement the interface. I might want to have a you know, a common rule that all my data structures are going to have a maximum capacity of 100, right? That can be a common rule which is going to be applied for all the data structures which are going to basically, you know, implement these methods add and delete. So in that case, I can create a final variable maximum size and give it a value as 100. So now all the classes which are going to implement my data structure will have this, able to use this property that, okay, the maximum size I can have is 100. All right, so let's talk about this. So as you can see, if I go to the implementation, I have two implementations here, stacks and queues. So in the case that this is a normal class stack implements data structures. Because it is implements means I have to write a implementation for both the abstract methods of my interface. So I have a public void add int data. I've now here written just simply just a simple print statement, because this is just for the purpose of understanding interface. Here I have simply written deleting from the stack and I returned a value of -1 because it had an integer return type, correct? Now suppose, say if I just remove this, let's say control X, it is going to give you an error, right? Because it says that you are supposed to implement all the abstract methods. Okay, so there were two abstract methods and supposed to provide implementation for both. Similarly for Q is also going to implement data structure, and I can have my own custom implementation here. So when should you use interface? Interface should be used when you have a scenario that you have some entity or some concept. Okay, like for example, here the concept was data structure, and I said that for this particular concept, these are the kind of behavior, because methods are nothing but modeling behavior, right? So these are the methods, or these are the properties which I want. Okay, I do not know the implementation, because for every different variety I want some different implementation. Like for example, stack would have a different implementation of addition and deletion. A queue would have a different implementation of addition and deletion, right? I can have some priority queue, which is again a data structure, which have a different implementation of addition and deletion. So what is common? The functionality of addition and deletion of data is common, but how to do that is different. That means how to perform a particular behavior is different. And when you have a scenario like this, you should always use interface. It's actually a very efficient way of designing your classes, right? So this is about interface. Now there is one thing which is specific to Java. After, I think from Java 8, there is this new type of method which has been there in interfaces, and that is called as default methods. As you can see, this is a word which I have used here, default. Okay, default methods are those methods for which you can provide implementation. Okay, let that sink in. See, first is interfaces cannot have, they should always have abstract methods, right? But then might be it is possible, like you will have some common functionality which is, need not be abstract. Like for example, here I have display. It's just going to say welcome to data structure interface, right? So I want this display method needs to be common between all the classes which implement my interface. If you have a scenario like this, what you can do, this is where after Java 8, this has been allowed. What you can do is you can define such methods, okay, because this is not an abstract method, because there is an implementation for it. You can define this by using the keyword default. These are called as default methods. Default methods, they belong to the interface. Okay, that means you can call this default method using all the stacks and queue will have access to the default methods, right? Default methods are those methods which have basically an implementation for that method, and they are common for all the methods, right? But then you also have this abstract classes, right? So let's try to, call these methods. So here, now one thing, right, because interface is just a blueprint, correct? You do not even have implementation for those methods. That means you cannot create a object of interface. Because to create an object of interface, I should be able to have a constructor, right? Something like this should be allowed. As you can see, it is not letting me do that, right? So that means I cannot, without constructor, how can I create an object? It's not possible. So that means for interface, you cannot have a constructor. If a constructor cannot be, added to an interface, I cannot create an object of an interface. If I cannot create an object, how can I access this? How can I access the display, which is the default method? You can do so by creating the object of the class which implements the interface. And that object you can assign to your memory reference of the interface type. Like for example, data structures. This is the memory reference, or this is the type, okay, which belongs to what? The interface. I've given a name, but the object which I'm assigning is of the class which implemented the interface. This is how you will create it. Similarly, data structures queue equal to new queue. Now I can say stack.add, right? Stack.delete, okay. This is queue.add is going to call the version of Q class, Q.delete is going to call the version of the, again, Q class. Now, if I want to access, the property, the final property, maximum size, which belongs to the interface, you can do so by using the name of the interface class. Very similar to static, right? In static methods could be actually called using the name of the class. Here also, whatever properties those final properties which you have inside your interface can be accessed directly by using the name of the interface, correct? Now the display method, which was the default method of an interface, this default method is been accessible by both stack and queue, and you can basically access it like this: stack.display and queue.display. Okay, let's try to see whether we can even do data structures dot, let's say I can, what we had, the default method was display. Now this is not allowed, right? As you can see, you cannot actually access your default method using the interface name. For that you have to use the object of the class which is implementing it. So let's run this simple, and it should give us whatever values we have, 100, right? So welcome to data structure interface is because we had this display method called twice. Okay, both are going to refer to the same method, so that's the same value which is getting printed. The value of maximum size was 100, which we had given. Here I'm saying adding 12 to stack, deleting from stack, and this is what, right? So this code you will find in my GitHub repo, which I will link it down. Right? I hope this is understood. So interface is very powerful. It's powerful than your inheritance. All right. So most of the cases you should try to use interfaces more. Yeah, because it gives you a more control over abstraction. So one of the way, or one of the powerful way of achieving abstraction in your object oriented programming is by using the concept of interfaces. Right. If this is clear, let's move on to the next one, which is abstract classes. Right. Let's talk about abstract classes. Abstract classes are those classes, okay, where you add the keyword abstract in front of the class. So let's say I have abstract class, and let's say, the same thing which I have given here, right? This data structure and stack and queue. I could have designed it also using abstract classes. What could I have done is, I could have said abstract class data structure, right? Because a class is abstract, okay, whenever your class is abstract, you cannot create object of the class, which is very similar to the interface also. Second thing is you can have abstract methods in this class, which is again similar to your interface, because all the methods inside the interface are by default abstract methods, right? So what is difference? The difference is you can have a class named as abstract and you need not necessarily have abstract methods. That means I can simply have a simple method here, public, let's say void display, right? And might be I can have an implementation here, system.out.println, let's say, print, something simple like that, right? So this display method, okay, is not an abstract method, and that is allowed. It's not necessary. This is again an interview question. Interview question says, is it necessary to have an abstract method inside an abstract class? The answer is no. It is not necessary to have an abstract method inside an abstract class. Once you make the class abstract, then you can or cannot have abstract method. But the other way around is, suppose if you have a method which is abstract, then you have to make that class an abstract class. You cannot just have a method which is abstract and just not make that class abstract. That is not allowed. Okay, so if you're going to model this concept of data structure, stacks and queue, we can do it using abstract classes also. So instead of defining it as an interface, I could also define it as an abstract class, right? So this is absolutely okay. So these are different ways in which you can model this concept. It all depends upon what are your goals and how do you want to model it. It's actually your choice, right? It has been proven that the use of interface is more flexible as your software will grow, okay, as you will extend, as you will expand your software. It is more better and to have code written using interfaces, right? So you have abstract class. Name of the abstract class is data structure, right? Now what we have, we can say these methods, which is your public, void, add, right? And it has an integer. This needs to be abstract, so we can just add the keyword abstract. Similarly, I can have then another abstract method, abstract public. Well, what is it? It returned an integer, delete. What are this? This is my abstract. Yeah. Now, if it is an abstract class, I need to have two classes which are going to implement my abstract method. So I'm going to say stacks and queue. These are my two classes. Now, how do I show the relation that stack is going to, override or provide implementation for these abstract methods? You need to do it using the keyword extends. That means this is done using inheritance. So I'm going to say class stack extends the class data structure. Similarly, class queue extends data structure. Now, do you see what is the problem or what is the limitation of using abstract classes? The limitation is because it uses inheritance to show the relation that this class stack is going to provide implementation for the abstract methods which are provided in this abstract class. It is due to inheritance, and in Java, you can inherit only from one class. Okay, if you can inherit from one class means you cannot have a scenario where you have two blueprints and from those two blueprints you want to, kind of provide implementation from that. Like for example, which we spoke about, if we could have an interface, one data structure which is an interface data structure and another interface which is of type algorithm, and then might be I could have a stack. Okay, and this class is going to basically override the methods of both data structure and algorithm. This was possible if data structure and algorithm were interfaces. But this will not be possible if data structure and algorithm are abstract classes, because inheritance does not allow, multiple inheritance is not allowed, right? So this is like a limitation of using abstract classes. Okay. So moving on, here if you say that this class is going to extend data structure, that means you are going to have access to, because it's inheritance, you're going to have access to all the methods of this data structure. That means you have access to these abstract methods. If you have access to the abstract methods, what are you expected to do is provide, implementation of these abstract methods. So there are two abstract methods, right? One is the addition and the other one is deletion. You need to provide implementation for both. Okay. Now for some reason, let's say you do not want to provide, let's say abstraction, you don't want to provide that, implementation for one of the abstract methods. Might be you do not know right now what the implementation should be, and let's say you just know the implementation for one of the abstract methods, which is add. Is this allowed? This is allowed, but then there is one thing, you have to make this class as abstract as well. Because you have inherited from data structure, that means all the methods which are present in data structure are available to the stack class, right? You have already provided an implementation for one of the abstract class, but there's another abstract class and another abstract method, which is abstract delete. And this method is also inherited, right? But it is still abstract. You have not provided implementation. So if you have an abstract method, that means you have to make that class what? Abstract. So that is how it goes. So if you provide implementation to all the abstract methods of the main class, then you do not have to create it abstract. But if you do not, then you need to make that class as abstract as well. Similarly, it goes to queue as well, right? So here also, again, similar to interfaces, you cannot create an object of abstract class for obvious reasons, right? But you can definitely create a object of the stack class, right? And similar to interface, you should be able to access all the methods. So these are the two ways of achieving your, abstraction in Java. One is interfaces and another one is abstract classes. But what is more powerful? As we saw, interface solution is more powerful and it is more manageable. Okay, so whenever you have a choice, try to do interfaces. Let's just see whatever we spoke about abstract classes on the example of data structure. So all I did is whatever we had actually, used this example for interface. So I just made the changes. Instead of interface, I made this abstract. So it was abstract class now, right? Now these methods needs to be explicitly mentioned as abstract, because inside an abstract class, you can have both abstract methods and non-abstract methods, right? The default method will now become a normal method. Okay, so this is the abstract class. Now stack is going to extend data structure. Okay, but rest all remains the same. Now let's say for some reason you do not provide an implementation for the delete method. Okay, then let's suppose if I just control X this, then what is going to happen is it's going to complain, because now you have inherited an abstract method, but you have not provided a implementation for it. That means you will have to make this class abstract as well. Then it is fine. Right? Then might be another class which inherits stack class might be then have to provide implementation for the method delete. Okay, I hope this helps. So like your interfaces, right? Like for example, if in the case of an interface, if you are implementing an interface, you did not have this choice. You will have to, provide implementation to all the methods of that interface. But that is not the case when you're doing abstract classes, right? Same for queue. Now when I have to, let's try to, make objects. So again here, as you can see, let's try to make an object of data structure. So if I say new data structures, right? See, it is not allowing me to directly create it. It is asking me to override these methods, right? Like if you can see here, I have to provide a overriding for these methods in the form of implementation. Then only it's allowing me to create the object of it, right? So I cannot directly create it. So instead of that, I've just used it as a reference and created the object of the class, which actually, has provided implementation of the abstract classes of the class data structure. Similarly for Q, then I can just simply call these, right? Now here initially when we were using interfaces, I was able to call maximum size by using the name of the interface data structures. Now because data structures has become a class, this I cannot call it directly by the class name, right? Because this is not static now by default. So this cannot be done, right? I can still access it maybe using the object. So I can say stack.maxSize. That is okay. But I cannot directly call it using the name of the abstract class, right? And you can use this method stack.display and q.display, which actually belong to the parent, which is the abstract class, right? So if I run this, it's going to be perfectly fine, right? So this is what it is. So just few changes and I was able to convert that example which I did using interfaces using abstraction, right? Though it says interface demo, but yeah, you get the gist. I have just changed it here to abstract classes, right? So that means abstraction of an implementation detail hiding can be achieved using two things in Java. One is using abstraction and the other one is using interfaces. Hope this helps.